Good morning. Welcome to Pantex. Yeah. We are fortunate to have you guys here today. I have been so excited to see the competition at Texas A&M, to see the competition at Tech, and this is the first time we're going to have it here at Pantex. So, welcome. Okay, there are a few things we need to go over, and I know you are probably tired of hearing this, but no phones, turn off your Bluetooth, your hotspots, you can't do that. As tempting as you may be to take a picture, please don't take any pictures. Mike has done an excellent job of taking pictures so far. Let's give him a hand. And also, we're recording the presentations so you can share with your family and friends. Okay, in the event of a tornado, guess what? You're in the right place. So the auditorium is the place you need to be. Now, if there's a fire, I always wanted to do this as an airline stewardess, right? If there's a fire, exit and go back out the glass windows that you came in, and on both sides of the parking lot are shelters, okay? In the event of fire. I always wanted to do that. That's cool. Okay, restrooms. I think you saw the big sign. We made it easy for you. You saw the signs for the restrooms, so everyone should know where the restrooms are. The cafeteria, you've already been there, you know where that is. The vending machines, as you walk to the cafeteria, they're there in the event that you need anything from there. I'd like to welcome your sponsors. These are the people who have worked hard to get you here today. From Texas Tech, we have Warner Kerr. He's the VP of Innovation and Entrepreneurship. Thank you for being here. We have Ryan Bain. She's the program manager of the Innovation Hub and Research Park. Thank you, Ryan. And then we have Jim Darnell. He's a professor of practice and the executive director of the Malloy program. Thank you, Jim. Okay, some instructions. The first team is gonna go back and get mic'd up. You're gonna have 2 lapel mics, okay? If you need more than that, you have this to use. You have a clicker. He's gonna show you how to use the clicker. The team that's up, you'll see the next team who's gonna come on deck. So they'll make sure that they're ready to go so we have a smooth transition. You have 10 minutes for your presentation, okay? Somebody's gonna give me the signal and we're gonna cut you off at 10 minutes. We may let you finish the sentence, okay? And then there'll be 5 minutes that the judges can ask you questions. And after those 5 minutes, we're gonna cut the judges off too, okay? Okay, we have, and you probably have received, we want you to judge the best video of the entire presentation, okay? And we have some prizes for the best video. And we also want your feedback, right? We want to get better and better at these. So we want to know, what did we do right? What didn't we do? So give us your feedback. We welcome feedback on that. Okay, I'd like to welcome the judges. You got to welcome the judges now. Okay, we have Wendy Baca. Okay, give Wendy a big hand. Wendy is the Director of Program Management. We have Carl Beard. Give Carl a big hand. We have Tiffany Lanier. Okay, you see Carl is the production operation division director, and Tiffany is our engineering division director and our chief engineer. Okay, so at this time, we're going to have Tiffany to come up and give us a welcome.
Good morning. How are y'all doing? Everybody had a good trip up? Hey, so I just want to take the opportunity to welcome you all to Pantex. I'm going to welcome you here on behalf of both our site office, the Pantex field office. They were unfortunately not able to be here due to the government shutdown. And all of Pantex. We are so excited to have you guys out here. You're going to have the opportunity to show off your skills and what you've done, and also get the opportunity to go on a tour. I think that's kind of exciting. Hopefully you guys are excited about that. Dr. Beard and Wendy and I are really just privileged to come and judge this. I'm so excited. This is, like Brenda said, this is the first time we've done it at Pantex. We do want to have, and it's the first time we've done a joint. We've done a few at A&M, we've done a few at Texas Tech, but we decided, let's get these kids in here together and let them compete against each other. I think a little healthy competition in the state of Texas is great. It's what makes us better at our jobs, right? We always want to be competitive with each other. Spurs those great ideas. But we are looking to continue to do this, expand it. So I do want your feedback, and just welcome to Pantex. We're glad to have you here.
Thank you, Tiffany. I just want you guys to understand how important this is to us, because we have 3 of our top managers that are taking time out of their busy schedule to be right here with us today. That's how important this Innovation Challenge means to Pantex. So give our managers another round of applause. We're running a little bit ahead of schedule. That's what I like. Are there any questions from anyone? The timer is in the back, so you'll be able to see the timer, so you'll see your 10 minutes. So not only will I be able to see it, but you will be able to see it. Okay, if there are no other questions, Team 1, want to go back and get mic'd up? Okay, Team 2, why don't you go back and get mic'd up as well, and then you can come over here and sit down. So this is what we call on deck, this first seat up here, or the second row of seats. want? Oh, you can. Let me know when you're ready.
Point the clicker to the back, too, just that way.
All right, team one.
Handling high explosives is one of the most Handling high explosives is one of the most unforgiving tasks in the defense industry. There is no margin for error and no second chances. For decades, factories relied on human hands, but even the most skilled operators are still human, slow, repetitive, and prone to error. Humans can only work so fast and with limited accuracy. Even minor errors create bottlenecks, delay production, and limit efficiency. But what if every step could be faster and flawless? Today, there's a better way to protect both people and mission continuity without compromising on control, accuracy, or accountability. Introducing the robot arm. It's a modern way to handle repetitive work in the manufacturing process with unmatched speed, accuracy, and consistency. Our system outpaces human labor, automating movement, minimizing errors, and streamlining workflow for maximum efficiency. The result? Faster production, fewer mistakes, and optimized output that means your team stays in control from a safe distance. Remote operation, full telemetry, instant shutdown, zero exposure, with maximum reliability. Whether your mission is stockpile stewardship, warhead life extension, or final dismantlement, automation doesn't replace the expert. It extends their reach and preserves their safety. National security demands innovation that's not only smart, but safe. You've always protected the nation. Let us help protect the people who protect it.
Howdy. My name is Matthew Valdez.
My name is Mohammed Omar.
I'm Adrian Montero.
I'm Robert Robles.
And I'd like to introduce you to Aura, the autonomous unmanned robotic arm. Now, whether you're designing high explosive ammunitions or sending up rockets suborbital, you usually want to make sure that there's extra safety so you're not risking extra human lives. The issue with that is an increase in safety usually means that your efficiency can start to decrease. What if I told you it didn't need to be this way? What if I told you Aura brings a system of autonomous robotic arms that not only maintains your safety standards, but exceeds them, all while multiplying your efficiency and production rates threefold? Now, what might a system like this, what should it be even do?
So our system, consisting of multiple robotic arms, has many constraints. Number one, it needs to have multiple fail-safes. For example, if the robotic arm carrying a highly explosive material is powered off while carrying it, we need to ensure that it doesn't drop it. Second, it must be nationally certified. Third, it needs to have a dexterous design. This means that it's nimble and accurate. And finally, it needs to have the strength of at least one human, because that is what it will be replacing. So what were our design criteria? Number one was safety. And this means we want to reduce the interactions between humans and highly explosive materials, and we're able to get it down all the way to zero. Second is reliability. We want to ensure that these robots are able to work 24/7, day and night, unlike any human ever could. Third is feasibility. We want to ensure that it's economically viable. Fourth is adaptability. We don't want this to be in only one part of the facility. We eventually want it to be in all parts of the facility. And finally, efficiency. These robots will be able to create more parts per hour than any human ever could.
Now let's talk about what Pantex, the integration of Pantex with Aura and what that could look like on a day-to-day basis at your company. Our initial plan for Aura is to handle the transfer of raw explosive materials with machines So in this schematic for the floor pan, you can see that Aura has access to the explosive materials and a machine. But before we start with the actual floor plan, we need to start about how we actually get the explosive materials into the room. We're aware that Pantex stores raw explosives in barrels on site. So our plan is to get a pallet and load it with the barrels, and then use a human-powered forklift to pick up the pallet and transfer it through the blast door. Then the forklift can leave. In a maintenance camera, there's going to be an operator always overseeing it, a human's overseer, and they'll confirm that no one's in the room. And using a dual authentication system with the forklift driver, they'll both confirm that the room's empty of all humans. The blast door will shut, and Aura can start its procedure. So, sorry. The Aura will open the lid of the barrel, take out the raw material, put it in the machine, and once it's finished, reload. And the overseer confirms each barrel to make sure it's done. Kind of like an automatic car wash, just each step being overseen and making sure that the procedure is always going smoothly. Then once the pallet's fully complete, the maintenance camera operator will confirm the blast door opens and a forklift can remove the pallet and replace it. The procedure is really straightforward. No human ever interacts with the raw explosives. They're never even in the same room, so it's completely safe. And then this procedure can be scaled out, so not just one Aura, but you can have 10, 20, 30, 100. The only real limit is space. And driving out here, we realized space is not probably a huge issue in Amarillo. So the future is really limitless for this. And then you notice I said machine of choice. That's because we know Pantex uses a lot of machines, and the same process can be repeated for different machines. So you have your CNC machines, X-ray machines, coordinate measuring, density testing. Any type of machine that Pantex is using can be operated with Aura. And then this isn't just for raw explosive materials. You can also use it for radioactive materials that you wouldn't want humans handling, or dismantling like bombs. You need the precision. We can add multifunctional tools to the Aura arm so that it can do different procedures. We can use automatic transport, such as an automatic forklift that can handle the pallet and place it in a specific place, so you completely remove humans operating that as well.
All right, because we're handling high explosives, we are going to design the blast room to be nationally certified so it can withstand blast in case there is an accident. I want to draw your attention here to the increase of safety right here. Typically, when people are handling the explosive, there's a risk. But with Aura, we can increase the safety standards by 50% by eliminating humans interacting with the explosive material at all. And because we're implementing robots here, the speed will obviously increase to 360%. In terms of efficiency, we've spoken with your Pantex experts, and they have said that the part per month is that currently Pantex can develop 50 parts per month. With Aura system, we estimate, given current industry estimations in other facilities, we can estimate the part increase to go to 112 parts per month. At each step of the manufacturing of the explosive, we can see a 44% increase of efficiency, which can scale up depending on which sections you decide to automate with Aura.
Now, let's talk numbers. The current system requires Pantex around $1 million per year. Our initial investment for Aura would be around $3 million. And while this is a large capital investment, not only would it pay back for itself within 3 years, it will also lead to a 225% increase in production rates.
Now, we've seen that Aura can bring you increase in efficiency, but also adaptability. You as a consumer can choose to put this wherever you'd like, whether it be in the CNCing process or coordinate measuring machine. If you're not comfortable with it being in a step, you do not need to put it in there. However, every single step you introduce will make this increase more and more in your production rate. Not only that, there is already an increase in safety and consistency to make sure that no insults can ever happen to this high explosives. Now, knowing all of this, I ask you one question. Why not Aura? Thank you for your time.
All right, you have 5 minutes for question and answer. Go ahead.
Yeah, thank you very much. Real quick, so a lot of our explosive parts have a lot of variability, both in size and shape. in form, so we deal everything from powders to what would be more crystalline to pressed. So talk to us a little bit about the ability for a single system to handle the variety that you would see among those various size, shapes, and forms.
Well, Aura currently at the moment is handling your hard explosives, so your hard plastic-like explosives. And the thing about this robotic arm is that it can be scaled up to different sizes and also be calibrated to hold on to different shapes. Right now, we're looking at a spherical high explosive. However, it can work even better with cubes, squares, rectangles, anything you really need. And for the powder, that is a future consideration we're looking at to see how we can accurately transport that as well.
Yeah, can you tell me a little bit about your inspection process and how you gain the efficiencies in the inspection process?
Because we have a teleoperator in a
Speak
remote
into the
room.
mic.
Because we have a teleoperator in a separate room, they will be able to remotely inspect the explosive as it's being produced when the machine starts and when it finishes without introducing the inspector into the dangerous explosive area. So that way we can still provide the level of inspection that's required for satisfactory explosive production without introducing any hazards of the inspector being around the explosive in its raw material form.
So just to follow on that, so your presentation talked about an efficiency gain from a time perspective. How do you gain the time efficiency in the inspection?
Right now, the efficiency is coming from the production, and we would assume then that the explosive enters the room and then it's produced, and you would have the inspector to remotely operate a camera to view the part. And I believe we did account for the inspection to be done within the limits of the camera scope.
And just to add on to that too, we targeted about, specifically, we're looking at 4 different steps to look at this 44.4% increase, and looking at industry trends from automotive and manufacturing for food. We looked at, there was 4 main things that a robotic and automatic arm was especially good at, and also how much it decreased it by. And so we looked at each one of these steps, and then we saw, adding them up, that it gave us a 44.44% increase per step. And now the inspection is also because we're taking into account for the coordinate measurement machine and density tests, the machines like that, because the human doesn't have to unload it and put in the program to test it and also track down the data from the machine can be wired to the control panel. So that way the person that is also operating the machine can also write down the data. So that way there's still no security issue for something going over wirelessly. There's still a cable that runs from that machine to the person controlling it.
Let's see. You guys might have noticed Pantex, except for this building, which is kind of new. The facilities are a little bit older, and so power distribution, electrical, that kind of thing. What are the requirements? Say you wanted to put more than one in a room. How are you guys needing power and that type of thing to keep everything up and running? We're talking just using is there a power supply or anything like that in case we had to operate that way?
Well, or it can also run off of whatever power grid you'd like it to. However, it can also run off of a generator, and it also will have its own built-in battery system in the case of any kind of grid going off, because we heard that's not really a big issue. However, in the event that it could happen, or it has a built-in backup generator to make sure that it can complete its tasks and be able to shut down efficiently without any kind of mishaps.
And one last follow-up on that, a little different. Is there a weight limit on the arm?
That really just depends to you. This can be scaled up and changed out however you'd like. If you have a different kind of weight, then that's perfectly fine. Most robotic arms, especially the one we're looking at now, has a strength of about 3 people. However, we rate it a little bit lower to make sure that it's not being pushed to its absolute limit. So we say it's rated for 1. However, it can really lift upwards of 4 to 5 people
All
as well.
right. Thank you very much. That's the end of our question and answer. Let's give Team 1, Aurora, a big round of applause. Thank guys. All right. Our next team is AutoChem, and I just want to remind you, if you're not mic'd up, come here and speak, because you want our video guy to make sure that he's recording this so that your mom, your dad, your friends can hear what you're saying. Okay, on deck is Barracuda.
Still relying on outdated reactor designs that put your employees at risk? Can you confidently verify batch-to-batch variability? After interviewing the employees at Pantex's nuclear facility in Amarillo, Texas, we discovered that the main concerns of reactor designs in industry use are the safety factors of the operators working on them and the lack of viability checks during the synthesis process.
We are AutoChem Analytics. Our self-driving laboratory integrates custom hardware and software centered around inline monitoring to optimize your synthetic processes.
Ensuring a reduction in hands-on operation while increasing the confidence level of your product quality for pilot and industrial scale applications.
Our mission is to influence national laboratories to initiate AutoChem implementation into industry standard.
AutoChem, let's get in line.
Good morning. I'd like to set the stage for you. Let's imagine that you're an engineering technician working at Pantex. You're working in the high explosives manufacturing unit on the synthesis team. Every single day, you're working hands-on with these batch reactors, and this creates an immediate danger to you. You constantly are feeling the subtle vibrations of these reactors under your gloves. You're smelling the chemical tang all around you, and you start to wonder, maybe this is a day-to-day deal. Maybe this is the norm, but am I really safe behind these blast-proof walls? Sure, they protect everyone outside of this room, but what about me inside? Am I really safe? What if one of these reactions spirals out of control? We are AutoChem Analytics. We specialize in custom design of your synthetic processes needs.
We are addressing a clear and prevalent issues. We just walked through a scenario where multiple different failures and problems could have arisen, and the reality of a huge risk being managed is a reality to many. And now that we've presented it to you, it is in the back of your minds as well. Now, with that scenario in mind, let's take a step back and look at the root problems of what we're trying to solve here and analyze. First problem that I'd like to address is that Pantex synthesizes its high explosives usually within batch reactions. This immediately causes a risky scenario as it generates and establishes a high explosive area. This directly ties into our second problem and challenge, is that at this moment in time, there's continuous need for hands-on operation and work within those high explosive areas. Technicians are required to manually control, monitor, and change the process with very little physical separation between themselves and the energetic material. These risks are not theoretical. They are daily, and with this current setup, they are unavoidable. And finally, our third problem, there is no inline monitoring to track key parameters within the synthesis, like particle size and chemical composition. Operators have no real-time feedback on reaction behavior or the product quality. All of these changes will go unmissed until after the batch, prompting reactivity instead of prompting proactive control.
What we're proposing as a solution to this is the idea of a self-driving laboratory. This has been around in the research space for quite a long time now, and it's usually done at the small scale. You can think of this analogous to a self-driving car. There's a driver who's in control, making decisions, but all of the gross mechanical needs are taken care of by the computer and the mechanical system. Ultimately, you want to get to your final destination and safe. If you've ever driven on the road, especially in an urban area, you might realize that a self-driving car is actually a little bit more unpredictable than a synthetic lab. Synthetic labs can be safe as long as we have proper preparation, safety things in mind, and we continuously monitor it. We can predict these things. So, in the last slide, you saw a robotic arm. I think that illustrates the idea quite well, but it's not necessarily needed for a batch scale reaction. This entire process would be automated by preparing all the reagents in advance, and those would be automatically loaded through a series of valves, tubing, or solid loaders if needed. Any kind of mechanical movement of the chemical once synthetic synthesis is started for cleaning could be handled automatically. We would need to know your specific needs to custom design this specific system. This is a software solution with hardware design in mind. Once the reaction is started, you will have constant monitoring of pressure, temperature, the things that you would normally monitor as a technician working directly with batch reactors. But this would be done completely remotely on a remote system where the engineer is removed from the dangerous situation. In addition to this, I want to emphasize and show you what we're really excited about is inline monitoring. This includes particle characterization, size, as well as chemical composition by using LCMS. Using this remote system in computers, we can also have a variety of safety interlocks that are all managed by the software, which is ChemOS. It's already developed, and we will design it for your system specifically. So how do we do that? First, we'd want to consult with your engineers, staff, scientists, and we want to know exactly what do you need. We can achieve any synthetic process automatically if we know what you have in mind. Once we know that, we can then design and mock up the system. Once we've done that, we would meet again with your engineers, staff scientists, and other stakeholders to ensure that what we're doing is matching your needs. Next, we'd implement it. We'd build your system. We would constantly be in communication with you to make sure we're meeting those previous needs. And then we test it. We'd make sure it works. We would make sure that your synthesis works, the monitoring works, and the safety that you have in mind is being addressed. And finally, we would train the people that need to know how to use this system. This includes everyone, and we want to make this as easy as possible so that it's more like a red light, green light scenario for the end user. Is the synthesis going well? Is it safe? Green light. Is it not? Red light. In addition to this, they would have constant communication between supervisors, engineers, scientists.
Circling back to our problems and the solution that we generated, they are all derived from our customer discovery and market research that we pursued during the innovation challenge that Pantex provided. We interviewed a number of Pantex employees with their names and job titles listed below. We asked them a series of questions and they gave us their intuitive knowledge and industry experience of our solution and the problems that we feel like are best represented. When interviewing Brenda, she noted that technician instruction still happens through very brief stand-up meetings in the morning. After interviewing Ashley, she echoed a communication concern, stating that supervisors are often physically far removed from the operational site, creating another barrier in communication. And after interviewing Barry, who gave us a ton of technical knowledge and ideas to make our solution feasible, he noted that particle size and key parameters are vital for the quality of the product, and being able to monitor them during the synthesis would be very vital. In our second set of interviews, after interviewing Matt, he noted that technicians aren't just hands-on, they are extremely hands-on and continuous to the process. And an acceptance of any new process from the national laboratories would be influential. And finally, after interviewing Caleb, Steve, and Cheyenne, they noted another communication issue is that between the process and non-process areas, these communication methods are pretty outdated. There's supposed to be another picture on here, but what is the value that we can provide after we've defined the problems, outlined the solution, and defined the why? It comes twofold. We can enhance the product quality and process efficiency through inline monitoring of the synthesis and through pre-validation after, before, and during. And also, safety. Safety is the number one thing on our minds. We are advancing the process safety and operator protection by decreasing the risk to operators by removing them from the hands-on operation, and decreasing incidents through predictive control and emergency interlocks. And by removing the operators from the operation site, we can potentially bring them to a place where communication isn't such an issue.
Who should we be talking to? We are going to keep these engineering technicians in mind as they will be using our product every single day. And we'll have a focus group of the synthesis team, and our direct buyer is going to be the high explosives manufacturing. However, we also want to keep in mind the influencer and also the saboteur of this, which would be the national laboratories. We want to make sure that they accept and approve of our new processes so that Pantex can better implement them, and vice versa. Here is our team.
I'm Robert. I'm a synthetic chemist by training, and I'm also functioning as a software designer.
My name is Mark David Flores. I'm a chemical engineer.
And I'm Anne-Marie Fritz. I'm a biochemist specializing in characterization.
Thank you, guys.
Let's get you in line.
Thank you.
All right. Thank you. Thank you very much. Now, the start of our question and answers.
Yeah, thank you very much. So I'm most interested in some of your inline diagnostics that you're talking about. So just a quick couple questions. So I think it was for impurities, you were looking at mass spec along with chromatography, and then for particle size, it said DLS, but I'm not quite familiar. So if you could talk a little bit more about the underlying technologies of the characterization, and then specifically, how are you going to assure you're getting a good characterization of the bulk volume, when you're taking, a very small sample out of that bulk?
Absolutely. So with DLS, that stands for dynamic light scattering. And so that process would be taking the solution from the reactor, which in the design, we would have a little outlet tube, and it would go into the DLS machine, and it would take a reading. And so we would optimize this process by having it done pretty often. So you could have it as often as you want it. You could test it every single 5 minutes, every hour, every 2 hours, whatever you want to set that to, just so that you can see, hey, so within our batch, if we take how many samples for DLS, what's the difference? And so when you take DLS, there's also a measurement called PDI, or polydispersity index, and that shows you the variation and differentiation between the different particles in that one sample.
And to comment on the chromatography mass spec, that's again obviously a challenge when you're dealing with a batch reaction. It would have to be taken at multiple locations, and you would have to have comparison between those things. This would be a software design kind of issue, is being able to analyze that data automatically to know that you're getting what you think you're getting. But again, we'd have to know the specific synthetic process that's going to happen to be able to design that.
So, quick question. What would you anticipate to be the timeline from the time you started your consultation or completed your consultation with the users and implementation and qualification of your processes?
So from just like a very generic standpoint, we would meet with you. That would probably take like 1 day. We'd ask for like a few weeks, probably 2 to 3 weeks, just to have a mock-up design on some sort of software such as SuperPro or ASYS or whatever batch reactor software that you choose or that we decide to use depending on either price or availability. And then from there, we would essentially walk you through the whole ordering process of your batch reactors and your DLS and LCMS as well, which it looks like Pantex already has DLS and LCMS. So if anything, what we would do is we would try to tweak the system that you already have and see if we can implement it into this inline design as well. But as far as reactors, it depends on the size that you're doing. So we heard that you guys are currently working with pilot scale. If you decide to go larger than that for industry scale, it would just depend on the manufacturer of your batch reactor for that timeline mostly. And then as far as like implementing, we'd probably say like a week or 2 weeks to put it together for you, and then training would probably be a month to 3 months for all of your employees.
To close that thing, that aspect of it out, what type of assessment did you do on like maintenance, calibration, all that type of thing to make sure that everything is clean and up and running, always, and so we're not accidentally, clogging up?
Absolutely.
Thank you for that question. Within industry experiences with comparable risks and processes, there's always scheduled downtime or maintenance scheduled. We call this turnaround. So that could be implemented with these control valves that we're implementing. We could either build it ourselves and have the schedule that we create, or simply adding on to it and creating the turnaround based on the industry that deals with these type of risks.
We always want to keep robustness in mind. We want to make sure the system is robust. Thank you.
Thank you.
Okay, all right. Thank you very much. Okay, Barracuda, and on deck is Intella AI.
Russia carried out new strikes on the country, including this massive wave
Saudi Arabia and Pakistan have signed a mutual defense pact just days after Israel's strike
between
on
an axis of powers which see the US and other Western allies as an enemy.
Threats to the United States are growing bolder and more powerful every day. In order to protect our country and our families, America needs to increase efficiency in weapon production to match these threats. Current Pantex CNC machining for high explosives requires intense safety precautions due to heavy human interaction with the materials. There is a dire need for change in the current system to ensure national security. Barracuda addresses this need for efficiency by cutting out over 50% of human interaction with high explosive machining. We've implemented automation to the CNC process through combination mill and lathes to reduce transportation between machines and a programmed robotic arm to move high explosives throughout the process. Our solution would decrease steps in the CNC process, increase the speed of production, and streamline the process further. Efficiency affects all Americans, and it starts with Barracuda at Pantex.
Howdy. We are Barracuda, and we're here to cut down on CNC manufacturing times for high explosives without cutting quality. Our core problem is that this current CNC manufacturing process for high explosives has several inefficiencies. Our goal is to locate and eliminate these inefficiencies to help streamline the process. A few weeks ago, during our customer discovery phase, we got the opportunity to talk to several Pantex employees. More specifically, we got the opportunity to talk to them about the current CNC manufacturing process for high explosives. It's a long and slow process, but ultimately, it's inefficient. Our team took a look at this process and found 5 design criteria to help guide our solution and streamline the process.
After our customer discovery, we found any viable solution needed to meet the following design requirements. Cycle time needed to be reduced by 25%, machine footprint reduced by 1/3, and the transport of high explosive materials reduced by 50%. Additionally, we would maintain Pantex's accident rate and defect rate of 0.02% and 0.74% per 100,000 work hours respectively. The first solution we considered was a laser grid inspection system. This would replace the need for a CMM and reduce steps in the process. Next, we considered a smart can and tracking system. This would partially automate the packaging time and reduce steps overall. Finally, we considered a combo CNC machine and robotic arm. This would fully automate the CNC process and reduce the need for transport and transport times as well. After weighing each of our solutions against our design requirements, we found our solution, Barracuda, would be the combo CNC machine and robotic arm.
The Barracuda system combines 3 machines that were once originally in 3 separate rooms behind 3 blast doors into 1 room behind 1 blast door. This greatly reduces the amount of human interaction with high explosive materials in the overall CNC process. The first machine is the combo CNC mill and lathe. The mill featured at the top and the lathe on the right that is able to function along a track, allowing you to cut at whatever angle is necessary for your given part. The next machine is the robotic arm that utilizes water-aided vacuum suction in order to transport the material from the CNC machine to the CMM. And I know what you're thinking. What if the robotic arm drops the material? Well, per DOE standards, the Barracuda system is fully equipped with a safety net, meaning that if the material is dropped, it won't be damaged in the process. The Barracuda system is also fully integratable with all of your current fail-safes, meaning that if water gets cut off or power to the building is shut off, the whole system shuts down, someone can enter the room, fix the problem, and then leave.
The Barracuda redesign is ambitious, but it's also viable. Combination CNC mill and lathe machines already exist and are used in manufacturing. The main difference with ours is that it's fully enclosed and compliant with DOE safety regulations. Additionally, water-aided vacuum suction is already used to handle high explosive materials during the CNC machining process, making it a safe and reliable method for a robotic arm to utilize when transporting these materials. Robotic arms are also frequently used in manufacturing as a tried and true method to reduce human interaction in the manufacturing process. The Barracuda system has a tremendous impact on the efficiency of your CNC machining process. We estimate that this system will save an estimated hour per part manufactured by entirely eliminating 2 human packaging and transport steps. It also decreases the transportation distance of high explosive materials and decreases the machining footprint, allowing you to increase production with the space you already have. What do you say to swimming with the Barracuda? Thank you, and any questions?
Okay, 5 minutes for questions and answers.
So if I understand your proposed solution, you're suggesting that we would have in the single explosive bay both the CNC machine and the dimensional gating, the CMM, and then transport it to and from with the robotic arm. And so if I got any of that wrong, please clarify it. My question related to that then is why not move to some kind of on-machine gauging instead of having the second dimensional inspection in the CMM and requiring that move?
Yeah.
That was actually one of the solutions we considered was the laser measuring system, but the technology just isn't there yet to be accurate enough to Pantex's like precise standards that you'll have.
And so on the robotic arms, so talk a little bit about, if anything, in terms of the explosive safety evaluations. I mean, any kind of things with twisting motions can be very sensitive to HE accumulation within the gaps that twist. So if you can, talk to us a little bit about, how do we make sure that the arm doesn't have pinch points that could cause us safety problems?
All the joints and everything on the robotic arm will be fully covered, meaning that like no dust particles or anything are going to get in there, gum up any like the systems and everything. Much like how like the CNC machine works, it's all fully enclosed, meaning that like all the dust from there stays in the one central area.
Have you done an evaluation on the cost to implement this change?
I don't think we've done a cost evaluation on this.
So a similar question, in terms of if we needed to increase our capacity, is there a way to mix and match, say, we needed more lathe capability and not as much milling, or is it kind of set up to only combine the 3?
Yeah, if you needed more lathe capability than mill capability, We could still have our combo mill and lathe machines in some of the rooms, and then in some of the rooms just have lathe capability, and you'd be able to save money on replacing all of your machines and rather just replace a few. And then you'd still be able to transfer them into the CMM.
Great. Thanks.
And then one final question. So you showed potential automatic transport of materials as well with, I think it was a little cart. So would those be handled with wireless? Would they be pre-programmed in terms of where they come and go? And if it's the latter, how do you manage the variability of where the material might need to be transported to?
So that was one of our solutions that we ended up not going forward with in research because that was the problem. We couldn't figure out a way to get it in a system that could fully go anywhere it needed to go. But we were originally looking at a track system for it.
Okay, before the next team start, we want to give the judges time to get their, all the information together. So don't start until the judges give me a thumbs
Thank you for
up.
your time. Thank you for your time. Thank you.
We have water for the presenters, so. You feel like you need some water. Okay, Auto 2, you can get on deck.
Hi, y'all. I'm Jonathan Maisley.
And I'm Rhett Davis.
And we're Intella AI, real-time intelligence, real-world impacts.
Where did this alert even come from? Hey, what's going on, man? I heard the chiller isn't working. I need to fix this guy. Go call the boss.
Hey, I'm late for a meeting. What's up?
We just had a major issue. We actually lost 30% of our product.
What? All right, I'm on my way.
Hello, I'm Antonio Griffith, and I'm with Intella AI. When alerts come too late, the damage is already done. In large facilities, technicians are flooded with hundreds of alerts every day through systems such as IntelliWeb. The overload leads to alert fatigue, where real issues blend with minor ones. When everything looks urgent, nothing feels urgent, and costly failures slip through. Seamlessly integrated with IntelliWeb, Intella AI provides a smart dashboard that visualizes system health, predicts failures, and reduces alert noise. The result? Less burnout, faster response, and smarter decision-making. Because here at Intella AI, we're all about real-time intelligence and real-world impacts.
First, I really want to thank William and Antonio for that video. They did an incredible job. It's a team effort, but wouldn't have been possible without them. So first, to really understand our solution, I have to address what IntelliWeb is and what Pantex currently uses for HVAC system monitoring and alerts and alarms. So IntelliWeb currently monitors real-time energy usage and building performance. It also sends alerts and alarms to a dashboard that technicians must monitor 24/7. It also is intended to streamline operations, but what it actually results in is considerable numbness to recurring alerts, as well as alert mischaracterization. This alert numbness, or what we've started to call alert exhaustion, directly results in human error. Additionally, alert mischaracterization results in both false high positive and false low priority alerts, pardon me. Those two problems directly result in capital losses with regards to both mission critical product and wasted man hours. In a 2024 study, it was actually shown that there was statistical significance between dysfunctional climate regulation systems as well as reduced employee productivity. Most importantly, these two key issues result in a direct threat to our nation's national security. So, what is our solution? IntelliAI is a robust, lightweight, on-site AI model that is going to take IntelliWeb's alerts and alarms, and it's going to apply finer filtering systems to be able to refine those alerts and make them a lot more useful for technicians. We're going to train this AI model on historical IntelliWeb data. We're also going to train it on corrections in work orders and technician responses. What IntelliAI is going to do is maximize operational efficiency of Pantex's operations and utilities group. It's also going to optimize technician workflow, and it's going to provide smart, actionable solutions for technicians. These AI-driven suggested fixes, these AI-powered responses for the dashboard, and nuanced predictive maintenance is going to offer considerable reductions in downtime, and it's going to maximize productivity. Remember, we don't want to cut out the technician. We want to augment their existing workflows and empower both technicians and employees.
Thank you, Jonathan. Okay, so during our customer discovery, we were able to get a lot of crucial insight into the IntelliWeb system at Pantex. So, to start off with, Roy Morales had informed us that the system was getting 150 plus alerts hourly. This is 3,600 plus alerts daily. Now, unless you're a Pantex employee at work, that's probably pretty annoying if you were getting those on your phone, all right? Now, Roy also informed us that there was a 90% inefficiency rating across site for every AC unit. Another thing, Barry had informed us that there was an estimated $4 million material loss in that 2022 incident that Jonathan was talking about earlier. Another thing I want to mention, Ashley told us that there was 400 Pantex employees that said they were dissatisfied with how the AC was working site-wide. When we talk about the product we're building, there are three key groups we need to consider. First is the buyer, specifically operations and utilities. They're in charge of efficiency and reducing wasted hours. So the value to them, well, it's cost efficiency as well as improving operations. The next thing is the end user, AKA the technicians. Right now, technicians suffer from exhaustion from all the alerts they're getting. So the value to them, getting rid of all that exhaustion. We hope to reduce the amount of alerts by a considerable amount so they don't miss crucial alerts. And finally, the customer, Pantex. Our value to them is offering expanded infrastructure, expanded safety, and expanded security through their already pre-existing strong infrastructure. When we compare ourselves to the competition, it's clear IntelliAI is the right answer. To start off with, IntelliWeb, which is currently implemented here at Pantex, is good for the time being, but it's already giving technicians a lot of alert exhaustion. And on top of that, there's no way to filter those alerts out. It's not helpful. And the dashboard can be kind of confusing at times. It's not fit for Pantex's specific needs. IBM Maximo has AI prioritization, but again, it's not fit for Pantex's specific needs either. On top of that, it's also it's also cloud-based, which means this could cause security issues as well as deployment issues. IntelliAI, on the other hand, is going to be ran on a local data center here at Pantex, as well as has AI filtering and prioritization specific to Pantex using Pantex data to train the model. Here's our value propositions, which aligns directly with Pantex's core values. Safety. Critical alerts means that we won't have any material loss, and national security will be safe, will be fine. As well as security. Off that same note, if we're able to keep the uptime going, no downtime, we can keep national security good. Another thing, expanding on their already pre-existing infrastructure. Adding IntelliAI is the right step towards keeping Pantex a global power in the defense industry. So here's our integration timeline. Right now, we hope to plan to get the IntelliWeb server out of Roy's office. Right now, it's in Roy's office, heating up his office, and it could also, his AC could also be out on top of that server being in his office, heating it up. Servers get pretty hot, guys, so that's not great. We hope to next train the AI model using Pantex historical data and filters. And finally, we want to deploy and onboard technicians to the dashboard. Here are our next steps. We already completed the Innovation Challenge at the Innovation Hub at Texas Tech University. Right now, we're in front of you beautiful people talking about our product here at Pantex in Amarillo. After this, we hope to score a partnership with Texas Tech University or Pantex. And after all that's said and done, we can start integration. Here's our IntelliAI team. You guys can stand up. And I just want to say thank you, Pantex, for having us here. Thank you, A&M students. Thank you guys for being here. My beautiful Texas Tech fellow students as well. Thank you guys. And we're IntelliAI. Real-time intelligence, real-world impact.
Come on stage so you can be there for the question and answer series.
Okay.
Okay.
All right, so just so you clarify for us, so is IntelliAI just a back-end AI module that will then attach to IntelliWeb, or is it an entirely separate software application?
Correct. It's going to be an attachment to IntelliWeb. We just want to basically make IntelliWeb better.
I do want to add to that, though. It is going to be a new dashboard with a bunch of new features, including suggested solutions, assigned alerts, as well as predictive maintenance. That's one of our biggest benefits.
So back-end AI with enhanced user interface.
Of course.
Right.
Yep.
Correct.
So talk to us a little bit more about how you plan to train it. I mean, you said you're going to take the IntelliWeb data and use that as your training, which is a good first step, but it loses any ability to take broader industrial experience into the training and the development of your possible indicators. And then, the IntelliWeb data is going to be limited in time. I mean, some of our HVAC systems go back as much as 60 years, which, we didn't have automated systems. So how are you going to deal with, that level of variability to really get to your AI system to give us maximum value and not be trained around a limited data set?
There's multiple steps to this integration plan. We do want to use IntelliWeb data first and foremost. That's what it's going to be analyzing first. And then technician responses for that industry specialization expertise will have that implemented as well. And really it comes down to the integration timeline. So how much time do we have to accumulate enough data? We can analyze data sheets for these specific systems. So if a certain alert is given, then it will give us a corresponding suggestion. And really with that, it comes down to how much data can we accumulate?
And just to expand off of that a little bit, it's been, what, 3 years since IntelliWeb was implemented here at Pantex, correct?
IntelliWeb has actually been at Pantex for about 10 years.
Ah, okay. That's a lot of data. So we'll have enough data to train this AI to be top-notch and really, really make a huge difference here at Pantex.
With two of the problems, one of them being the HVAC being really old at Pantex. I know you guys use Carrier and Train for your HVAC units. So in realistically scenarios, you want improvement on the AI model answers. So based off that, the technicians that would use the new models in the future that were replaced by Pantex would then base off the AI model for them.
I know it's a long-winded response, but really I want to emphasize completed work orders. Completed work orders, there's a big backlog of that at Pantex, and if we can match alerts to those work orders, then that can be huge for training this AI model.
So when you talk about those completed work orders, are they in the digital platform that you need to be able to use them?
We'll probably have to port them into the digital platform, but luckily with the advancements that have been made in AI, one of the big bottlenecks back in the days, maybe even a decade ago, was you needed all your data to be like specific, of one specific type. Nowadays, AI has become a lot smarter, and these algorithms have been able to adapt to various data types, and that's something we intend to leverage in the training of this model.
And is your AI platform proprietary, or are you using one of the commercially available platforms and adapting it?
We do plan on making it proprietary and specific to Pantex and the specific data that we'll be able to have access to, but we do intend to leverage the recent advancements in AI and try and kind of base our solution off existing models. We want there to be quick integration. Designing our own model from scratch would be incredibly difficult, and we don't want that to really hurt our timeline for integration.
Yeah, so which platform do you prefer?
Personal preference, I don't know if there's not going to be a specific platform. We've done a little bit of research into Anthropic and ChatGPT, the larger models, and they do have resources for individuals to build their own models based off of that. But it is something we're going to look a lot more into so we can make sure that we really hone in on what Pantex specifically needs.
All right. Thank you very much. So again, we're going to give our judges the opportunity to complete their sheets, and when they give us the thumbs up, you can begin. And really try to speak into the mic since we're recording, sort of like this, right? Judges, are you okay? You need a break? You got plenty of water? Okay.
audit tool. As you know, there are over 120,000 special tools at Pantex. Now, what do we mean by special tools? We mean workbenches, we mean test stands, we mean hoists, anything to help with the design of high explosives here at Pantex. We're not just talking about screwdrivers, your nuts, your bolts, or your hammers. Hundreds and thousands of tooling parts enter daily here at Pantex. Now, what does this mean? This means your maintenance technicians constantly working, and this means repetitive tasks. And what does this result in? This results in fatigue and repetitive tasks. Now, ladies and gentlemen, raise your hand if you felt energetic at 9 a.m. starting work. And towards the end of the day, perhaps 5 p.m., you felt exhausted, you felt drained. I get it. Me too. It's the normal human tendency to feel exhausted and drained after a long day at work. Now, according to the National Institute of Health, over 43% of workers have self-reported that they feel sleep-deprived after a long day at work. This is a bad statistic. Now, what does this lead to? This leads to productivity losses. You could lose over $3,000 per employee annually just because of this. You're not just losing money, but you're losing time and you're losing resources just because of failed inspection and just because something didn't go well. Over here, that could have been avoided. So what's the main problem here overall? Human error.
So currently, there are over 300 product and quality technicians at Pantex. Now, you guys got one of the most critical missions in our nation's defense. So maintaining the highest standards of inspection is essential. We found out that after a worker has worked a full shift, their productivity has dropped by 20%. Think about it. Working for over 6 hours is already exhausting, so expecting complete focus is unrealistic. The tools being inspected at the end of the shift are just as important as the tools being inspected at the start of the shift. Now, this poses a big risk because these special tools are being worked on high explosives. So this brings us to the problem we're trying to solve. How can we ensure quality automated inspection while minimizing human error? We, AutoTool, will ensure this by offering an autonomous robotic system that ensures reliability and efficiency. Now let's take a look at our scoping decisions.
As we began to explore the problem space, we uncovered 3 main inspection types that happen to your tools: geometric inspections, material inspections, and electrical inspections. However, we decided to focus on the biggest of the 3, geometric inspections. We understand that each and every part and tool, for the majority, has a legible part label. We will be utilizing this as a key part of our solution. And finally, we understand that Pantex designs and manufactures a number of custom tooling parts. To do this, CAD files are used. Once again, we're going to leverage CAD files in our final solution.
So this leads us to our different design requirements that are going to be needed in order to ensure a viable solution. The first is going to be geometric detection. This is up to 1/10 of a millimeter. Tool size accommodation, which will be 8 cubic feet, ensuring 80% of your tools fit within it. Inspection time reduction by up to 50%. Collecting data and storing it in already integrated systems. Tracking a tool's health and making sure it is taken out when needed. And automating a system up to 99%.
So, as we approached this problem and tried to solve it, we felt that the first obvious solution was a CMM machine. But upon further investigation, we didn't really feel like it got to the root of the problem at hand. So we went back to the drawing board and came up with 3D photographic scanning and autonomous humanoid robotics. But again, none of these really got to the root of the issue. So in a bold move, we decided to combine all 3 into one complete system.
Meet Auto CMM. So picture this. You're in the tooling inspection part of the Pantex plant. A number of tools come in on trays into our system, and then an autonomous robotic arm will pick up each tool and place it exactly where it needs to be in the staging area. Next, we'll use an AI computer vision model to detect exactly which tool is being inspected at that moment. Then, using that data and comparing it with the CAD file, our CMM will come in and test tolerances up to 1/10 of a millimeter at various different points of the tool. From there, we're going to track that in your existing enterprise resource planning software, SAP, and then we're going to use the autonomous robotic arm once again to place it in either a pass or fail line. We plan to use AI not only to detect which tool is in the staging area, but also detect trends over time. So let's say 1 week we have this part that has 0.01 tolerance, and then later 0.05, and then even later 0.1. You can see there's an obvious trend over time, and we want to predictively pull these tools and parts out of production before they cause real issues. My name is Noah Johannesson.
I'm Dr. Peterson.
I'm Arati Devakumar.
I'm Hadi Chaudhry.
I'm Zindi and you.
And we are AutoTool. We would love to join you in implementing this system at your plant.
Thanks for that. Let's see, I wanted to double check on scaling from size back and forth to size of different tools and how quick that can happen, and you know, if there are any limits that you guys realized you're going to have.
As I've said, it's going to be an 8 cubic foot area, which we talked to some of your coworkers, employees. They said 80% of tools will fit within that. So scaling wise, a lot of your tools will fit.
So a lot of the tools have pretty unique features, and some of those might be hard to see, hard to get to. How is it going to maneuver? Is it an entire tool that goes on this device, or is it piece parts of a tool that go together later?
So it would be the geometric tolerances of each of the pieces of the tool. So there would be some disassembly required in the beginning, so we could track each piece of the tool individually and replace them as needed.
So when you talked about the labeling that's on the tools, the labeling on the tools I don't believe includes the piece parts. How will you maintain the inventory of each of the piece parts for a tool assembly?
We weren't aware of that. We thought it was each piece was labeled. So that would be an implementation question we would figure out while we were trying to implement this system for y'all.
So you indicated that you'd have both optical dimensional analysis as well as the traditional CMM. Talk to us a little bit about the timescales between those two, and then based on that, why did you choose to sort of integrate those into one machine as opposed to having a sort of a split option of being able to move it to either optical or CMM?
So the optical portion was just to determine which part we're tracking, so we can link the data to that specific piece and track it over time.
Okay, so you're not doing dimensional gauging with the optics, you're just using it for identification, and then you're doing all of your dimensions on the CMM?
Yeah.
So how do you work do all three aspects have to pass before we move forward, or is there a plan for, yeah?
Restate that question for me, make sure I understand what you're asking.
Sorry. So you got the CMM, the 3D, and then you're using the robotic arm. Is there anything that you set up to where one of those fails and then the whole tool fails, or it's going to be just based on the combination of all three, or are we going to?
So it would be a combination of all three. If one goes down, we'd have to do maintenance to the system.
Mm-hmm.
But if we were able to implement multiple systems, that wouldn't be as big of an issue.
Okay. Thanks.
And what would you anticipate the cost of this system?
So we were expecting that question. We did some research. We found that the normal CMM is about $100,000, robotic arm's about $5,000. And then the AI we're thinking is going to be about $5,000 also.
All right. Thank you. You guys have really been very efficient. We are ahead of schedule, so we have some time. Okay, our final team is Rank Shields.
That was a 50-gram controlled explosion with a 25% overtest. Now I'd like to point out this timer in the top right corner. It's currently at 2.5 milliseconds. It's explosions that can count in milliseconds. Now to date, Pantex has never had an unplanned controlled explosion of this magnitude. That is 100% due to the emphasis put on safety on every level by each employee. Every day, men and women come to Pantex and work with this much power. Mothers, fathers, husbands, wives, sisters, brothers, people, all come and put their lives on the line for our country. But if something did happen, the only thing standing between them and the potential for an incident of this size is a blast shield. My name is Winnie Keller, and we are Rank Shields, protecting those who protect us. Now, the initial problem that we were given was to find a benchtop blast shield that was suitable for a laboratory setting. Currently, there is only one commercially available option on the market, and these custom shields take an excess of money and time to attain. These are valid issues faced here at Pantex. However, we wanted to dive a little bit deeper, which brings me to our customer discovery. In our customer discovery, we found that there were two main issues that our customers faced. Number one, who likes to do paperwork? No one? Of course not. Now, I mentioned that there's only one commercially available option on the market, and that these custom shields are, put bluntly, a pain. Well, Pantex has over 150 unique pieces of lab equipment. That's 150 vendor vettings, 150 product testings, 150 product requisition forms. That's a lot of paperwork, and rightfully so. Security, integrity, and safety is everything here at Pantex. However, these are some actual quotes from Pantex employees on the screen. You can see a theme here. Bureaucracy and paperwork is a bit of a headache, and it is our job to make our customers' lives easier. With that in mind, problem number two, Pantex has land, funds, resources, but no grant can give the one thing needed most: time. You can put up a laboratory, you can put up lab equipment, but how quickly can you put up a blast shield? How quickly can you even obtain one? How quickly can you ensure to your technicians that they will go home to their loved ones tonight? That being said, I present to you our solution.
Every day, men and women step into high-risk environments, handling, testing, and building with explosive materials, all to protect us. But who protects them?
We know safety isn't optional, it's essential.
The solution?
Introducing Ring Shields, where safety and your protection is our #1 priority. Affordable, adaptable, mobile. Ring Shield can follow you wherever and whenever. Benchtop labs, outdoors, or even on site. Wherever a blast shield is needed, Ring Shield is there for you.
Built from dual polycarbonate panes and infused with non-Newtonian fluid, Ring Shield is reinforced with steel T-slot framing, delivering protection that adapts instantly to any environment.
Non-Newtonian fluid hardens instantly with every collision, dispersing energy with every strike.
So why is it that when you mix water and grains together, they suddenly get so strong? You would think, if I hit it really hard, I'm going to break it. This is a fluid normally, and if I hit it hard, it turns it into a solid.
While dual polycarbonate panes add extra layers of strength, giving you unmatched impact protection.
With a design built for real-world use, 4 times the shock absorption of a normal shield, less than 1 hour assembly time, and one kit consisting of a 3-pane, 1-base system can be moved by just 2 people, so no extra moving equipment is required.
Lock it, expand it, move it. Ring Shield's T-slot framing system and clamp base let you build protection your way. Ring Shield stands ready when it matters most. Ring Shields, protecting those who protect us.
This is the Ring Shield. Now the first thing that I'll point out is this flared base. This base is weighted, meaning it's suitable for indoor and outdoor use, and maintains that the shield stays a shield and does not become a projectile. Now on to the pane itself. The pane has 3 layers. 2 1-inch thick polycarbonate panes with a non-Newtonian fluid in between to increase blast absorption. Now I'd like to show you all my favorite part. How many of you have ever bought those little magnetic building blocks for your nephew or a kid or yourself? I'm not judging. Well, what if you could customly assemble a blast shield with such ease? The aluminum frame has T-slots attached on each side, top, bottom, left, and right. Meaning, not only is this base detachable, but you can easily snap these panes in and out to one another. Now, we did run these T-slots and the joints through an AutoCAD simulation to ensure that they would not be weak points. So you want a custom blast shield? You can make it. You want a 2x8 blast shield? You can make it. You want a 16x32 blast shield? You can make it. You want a blast shield in the shape of a double T? You can make it. All with one product, 1 vendor vetting, 1 product testing, 1 product requisition form, 1 Ring Shield. We estimate that from box to fully set up, it will take under an hour. Now, safety is our #1 priority. So, we consulted the Department of Energy Safety Standards Handbook, specifically chapters 12 and 17. We figured they might know what they were talking about. We meet the requirements for a Class 1 safety rating, meaning we can account for overpressures greater than 5 max PSI effective pressure. We can ensure that structural collapse is not a possibility, and we can account for fragment and debris as well as thermal flux. I'm going to pass it over to Ethan to tell you all a little bit more.
Thank you, Winnie. Hey, everybody, my name's Ethan Rojas, and let's just jump right into the customer segments. Now, our #1 client will be Pantex. However, our #1 customer will be the Explosive Technology Senior Director, Monty Cates. Now, he'll be the one purchasing our product. However, he will not be the end user. Now, the end user will be the explosive technicians, and those will be the lives that our product is protecting. Looking to expand it even further, we could go to other explosive labs that are facing a similar problem as Pantex, like Sandia, Livermore, perhaps even the DoD. To expand it even further, we could go to other universities, factories, perhaps even local gun ranges, anywhere where you have explosives and fragments flying in the air and you need to protect your people, we can be there. Now, we did a small market comparison analysis in Pantex, and we noticed there's only one other competitor in Pantex other than their own custom blast shields, and that was Total Shield. Total Shield uses a 1-inch thick polycarbonate pane. We're using double. And with the non-Newtonian fluid added, we have quadrupled our shock absorption. It takes Total Shield 4 days to get their product up and running and ready to go. It takes us, as Winnie stated before, under an hour to get our product of a similar size up and running and ready to go for the field. It is $4,000 to $10,000 more costly to go with Total Shield than it is with us, so we are much more cost effective. And although Total Shield sends their blast shields out in parts, once it's all fastened together, it is a lot harder to take it all down and put it someplace else. Ring Shields is faster and easier to disassemble and assemble, only in a matter of minutes. Moving on to our value proposition. In the DOE Safety Standards Handbook, 1-inch thick polycarb is rated for 50 grams of explosives. And as I stated before, we're doubling that. and with the non-Newtonian fluid added, which, fun fact, is actually twice as penetrant resistant than Kevlar based on the National Institute of Health research study, we have increased our total shock absorption. We're also very adaptable. We can go on the field, in the field, out the lab, in the lab. We can build upwards, sideways, diagonally. The sky is the limit. Not only are we saving you money on the front end, but we're also saving you time. And we all know time is money. With the reduced assembly time it takes to make these blast shields, and we're also very versatile. You want us on a bench, on a table, out on the field, or even on the cold floor. Wherever you want us to go, we can be there. As for our next steps, we do plan on commencing our first phase testing, then moving on to our design and manufacturing, and then expanding our customer base. Thank you very much. These are our members, and we are Rank Shields.
All right. Come on up, team members. And remember, if you're speaking, to speak in the mic.
So, a couple of questions. First, is it primarily designed to shield against fragments, or are you actually intending to shield against the shockwave itself?
I love that question. Here, if you go to the next slide, here we have used the table 17.1 in the laboratory operations. We looked at the very bottom. Here it's stating for 2 plates of polycarbonate with an air gap in between. That is rated for a steel confined 50 gram of explosive. That is the worst possible case scenario. And that is exactly what we designed it for. But without the air gap, we're replacing the air gap with the non-Newtonian fluid, which is how we get our novel idea.
And to add on to that really quickly, the specific non-Newtonian fluid that we chose, which is polypropylene glycol with a fumed silica mix, when it is exposed to heat in the incident of a blast, it actually turns into a gel, which would additionally account for that fragment and debris as well. So it works in the case of both settings.
And so if I understood you correctly, the shield is just held in place by the weight of its base alone. Do you have any kind of attachment capabilities? And if not, then what is the maximum kinetic energy or shock you can take without tipping it over?
Sorry to interrupt you. I'm very glad you asked that because I actually left that part out. The base does have retractable clamps within it, so those clamps are made to attach onto any benchtop or any other surface that you have.
And do you know what those clamps are rated to in terms of the force they could take before failing?
Yeah, if you could go to the next 2 slides. Next one. So it is using these gusset plates to attach to the polycarb, and we're just going to use, high-speed steel to drill out these holes. And so with these gusset plates, we noticed that we're using tested materials already. We have yet to test it, but we are using tested materials already. Actually, in Total Shield, they're actually using a similar attachment to their plates, but they're not as strong and beefy as ours. But so if we're using like I said, using the tested materials already.
And I would like to add on to that question. In addition, on the bases, we're using T-slot clamps, which means that they're modular, and if in the chance that you have a greater blast and you need more added weight to help support the shields to deal with so it doesn't become a projectile and it stays more modular and fit for any environment, we've also added a function to where the bases can slide and clamp into each other to help with stabilization to deal with greater blasts.
So talk a little bit about the shelf life and like maintenance and, what happens if because it's hopefully never going to be used, right? So, but what should people be looking for in terms of we got to replace it, it's too old, can you pull the, material out of the T-slot, that kind of thing? How far did you guys get on that part?
Yeah, so these are designed to just stay there, you put it in place, and if you want to move it, you can move it, but there's no degradation of materials, there's no thing, because it's made out of aluminum and then polycarbonate, and with the non-Newtonian fluid, we don't have to do any maintenance whatsoever. So you can just sit on your shelf, and it can stay there.
And in addition, the type of steel material that we're using, which is steel ASTM A572, is a higher grade steel than what's commercially used or what's used in the average now produced blast shields. It has a longer shelf life and is also better to withstand greater amount of power and force that would be used just in case.
Great. And one last question, you might have said this. How heavy is one?
You want to go back one? So we did the calculation. How do you find mass? It's just density times volume. So that's what we did right here. And we saw at the OSHA standards for a 2-person lift is 100 pounds. So we got right underneath the 2-person lift.
And so what's the cost of one module?
So we sell these in a starter kit. That starter kit comes with 3 panes and a base. Our starter kit comes $5,000 compared to Total Shields, which is $45,000. Each panel we sell for an additional $1,000 each.
Okay. Thank you very much.